Remember when we talked about probabilities and we said all your probabilities add up to 1, the area under the curve adds up to 1. So using your probability statement is a good way to kind of tie that together. So if all your probabilities have to add up to 1, you're only dealing with this little section down here. So what is the probability that your z-score is going to be less than negative 1.33? About 9%. That's my probability that that will happen. Now, what does that mean, that z-score of 1.33? We'll eventually get to that. We'll put values there, say, like a weight of a cereal box. If it's less than a certain amount, and you find your z-score, and then you measure your z-score off of that. Eventually, we'll tie this into a little bit more things. But right now, this is where I want you to be. Are you good with that? Put your probability statement next to it. Because that was the only thing left we had to do was pull in a probability. But I wanted to wait till we had something to see what probability meant. Now, I gave you a z-score of 2.34 and shaded in the right. So how would I write my probability statement for this? .34. Good. And what is the area that you found to the right of 2.34? So 0.9904. So now, is this little piece greater than 50% or less than 50%? Less. So could it be possibly be 99% of my curve? So what did I have to do? Subtract it from 1. Because you find the area to the left. Your area on the right is 1 minus that. But do you see how your sketch helps you? I need to know 0.9904 to be able to finish this. However, I know this can't be 99% of my curve. I'm only in this little part here. Since I'm greater than 2, since z is greater than 2, isn't this an unusual amount? An unusual, isn't that less than 5%? Like when we tie this all in together? So you can kind of see this starting to come together a little bit. So what is 1 minus that guy? 0.
0.96.
Thank you. Okay. So again, if you did this one on your calculator and you're doing to the right, just in case you want to get familiar with this, I now know my lower boundary. I don't know my upper boundary. I want to go from here, beginning here, lower, to up here. So now my lower boundary is at my 2.34, and my upper boundary, 9999. Paste. And there's your answer. See it? And we round it. Your calculator, of course, is far more exact. Our table rounds it off. They round your z-scores off to 2 positions, and they round your areas off to 4. Okay, how about this guy? We need to make a probability statement for this. My probability is z is what? And less than. So I want an and statement, right? I want the guy in the middle here. So I'm going to put the z in the middle. Good. Yeah, because you want to make an inequality statement. I want my z to be between, what is the probability that z comes between these two numbers? If you did it as the probability that z is less than negative 1.23 and the probability that z is less than positive 1.23, you really wouldn't find that you're using the difference between here because you want to know where they overlap is because of your and statement. So we don't write it like this. We write it like this, like a true and statement. So we know there's our lower boundary, there's our upper boundary. This is where your calculator works really nice because here's your upper and your lower. So I'm negative 1.23. This is the one time I always use it for this guy. And I'm going to paste. Okay, so 0.7813. Is that what you guys got? For those of you that did this without the calculator, who didn't use a calculator? Who used their tables? Hey, Will, what'd you do?
I found the total area of positive 1.23.
Okay, what'd you get for that?
0.8907.
Thank you.
And then I found the total area of negative 1.23.
Which is?
1.1918.
Okay, and what'd you do to those two guys?
Subtract.
Subtracted them. So we find area of one, and we subtract out the area of the smaller one. Good. Area is never negative. Area has to be measured in a positive value. So you always have to subtract the smaller minus the larger. Good. Any questions on this part? You good? All right. So, would anybody like to come up and do number 4? Give me a sketch. See that? Give me a sketch. Find your probability. Your sketches are just like rough sketches, just so that I can see you know where to find the 1.54, where your shading goes. That also tells you, should my answer be less than 50%? Should it be more than 50%? When it's to the right, it's a good hint because if we're looking for a little small area and we looked up this big, huge number, we know we have to subtract it from it. Okay? Did you find your area to the left?
Yeah.
Okay. Guys, what's this here? Okay, everybody agree? Okay, Jayla, nice job. Now, how would I write this as a probability statement? The probability that what? And how did you know it was less than? Because you shaded to the left. Good. Good. Okay? Anybody want to do number 5? Okay. Go, baby. Let's cheer for me. Go, baby. Give me the arm. Give me the hand. Give me the. Give me the. Give me that. My turn. Give me there, but me. Let's sketch the way you sketch this. Whatever way you sketch this, sketch that way, and we can see everybody's different types of interpretations and see where we're going with this. Sorry, I didn't have my morning coffee. I had a meeting and I didn't have a cup of coffee. I'm not nice without my coffee. Good. Notice she put that right before the negative 1. Oh, good. It won't erase. Just, yeah. Yeah. I don't know why it doesn't erase. Okay. Good, thank you. Now, if you, you did a great job. When you look this number up, negative 0.95, you find a number less than 1, right? But isn't that area greater than 50%? So it tells you to subtract that from 1, right? You find an area less than 50%, I meant. So it should be greater than 50%. So therefore, we're going to subtract that area from 1 to get a larger number. And doesn't that make sense? And look how close you are. Tie this whole thing in. Half of your graph is 50%. From plus or minus 1 is 68%. So from 0 to negative 1 is about 34%. She almost went to the negative 1. So I'm almost looking at 84%, right? My answer should be close to 84%. But I want you to make sense out of this, and you did a great job with your probability statement. Okay, next one. Where's my next student? Will, thank you for volunteering.
Alright, I don't know if I'm gonna be able to read it or not.
You're right. Do you need numbers on it?
Why is it writing above where I didn't?
See, this is always good when you guys write up here, so you feel sympathy for me now.
Yeah, thanks. No, I know how bad it is.
Total sympathy.
Look, like I can start here and it writes above.
Yes. Total sympathy for me now.
This is why I didn't want to come.
Oh, you're doing fine. You
What
volunteered.
is
You're
it,
so
6?
kind.
You want me to do a probability thing?
Sure, that'd be great.
Okay, I'll give it a go.
Give it a go.
Is that right?
Yes.
Okay.
Left. Good. L.
Alright.
Good. Very good. Now, before Will put his answer up here, guys, before Will put his answer up here, we noticed it was less than negative 2. It was almost less than negative 3. So it's on towards our very unusual. So shouldn't that tell us, yes, less than 5%? So right away, isn't his answer less than 5%? If you put an answer up that was 8 over here, I would have said, let me look this back up and see if this was right. But if you can kind of get a good feeling for what do I expect, you'll never be off. You'll know what that your answer is good or not. So very good. And Will gave us a probability. Less than, left, L. So they kind of go together. Anybody want to do number 7? John, was that you? Thank you. Thank you for raising your hand.
Number 7?
Sure.
Yeah, 1 minus 0.9.
Oh, come on.
What?
Come on. You love to talk, so now you can address the class. So you can address the class. You didn't want to be stuck over there, so now you're in front of the class.
Oh, yeah. That's a little small.
It's not going to erase. I don't know why.
Oh, man.
It's okay. You can do it a little. All right.
I'll work.
Now you feel my pain, right? Yeah.
Yeah, the system going against me. I'm trying to do something.
You're doing great.
That's what I'm saying. Like, I'm getting criticized.
No, not from me.
No, we're just laughing.
Alright, I'm not working with this side anymore.
These things happen to me every day. I'm up there, John, every day. And
Painful.
I don't know why.
It's gotta be painful.
I think it's because it's like a Microsoft Word document.
But I've been using the document all my life on these smart boards. The smart board just drives me crazy. So, right. He shaded to the right. He knew when he looked up this answer that this couldn't possibly be the answer, so he subtracted it from 1. So, probability statement. Z is greater than 1.45. What is the probability that my area under the curve for this z-score, what is my area under the curve for this z-score? Okay, good work. All right, do we have just two left here? Two betweens. Any betweens? Everybody avoid eye contact. I'll do one and then somebody can do the other. All right, so between. So, negative 1.5. Where do I find negative 1.5? 3. Between which two integers? No. Negative 1 and negative 2. So this is my negative 1.53. I want this area, it's going to find my area to the left. I want 1.75 between what two integers? 1 and 2. Now, when I look this up, this is also going to find my area to the left. If I subtract them, I'll get my area in between. So I look up this area. Anybody have the area for negative 1.53? 0.630. And for 1.75? Okay, and what do I do with those two areas? I subtract them. And I always subtract the larger minus the smaller. I don't subtract my z-scores, only my areas. So subtract them, and this will be your answer. And between plus or minus 1 is 68%. Almost to there and halfway to there. So I expect that to be larger than 68%, right? A good chunk larger. And 89% is a good chunk larger. So my probability statement says z is between less than, negative 1.53, I don't know why that's doing this, 1.75. Okay. Anybody willing to do this one? That's the easy one. You don't even have to look anything up. Alright. Guess I'll have to do it. Where do I find z equals 0? Where is z equals 0? In the middle. Okay? And 1.75, we just looked that guy up. So I want the guy in between. When I look up the 0, what percentage of my curve is less than 0? 50%, so 0.5. 1.75 we just looked up. 0.9599 and subtract these two. Okay, and there's my answer. And that's a good chunk of your curve. So the probability that z falls between 0 and 1.75. Did everybody get the probability statements down pat? Any questions on the sketching? So looking it up in your table. Calculator? Did you try the calculator? At least try it once or twice. The between work really nicely. Because what the between does is take your whole thing away. You don't have to look them up. You don't have to find it anywhere. You don't have to subtract your areas. It does everything for you. You put in your two z-scores, it does the rest. And there's the rest of it. And just round it to 4 decimal positions.
When you write the betweens, like you're always going to use the less than.
The less than sign because you got an and statement. So an and statement puts this smack in the middle between the two. And ors will do this differently. They'll go in different directions, but an and will always be between. Okay. That was a good question.